If the distribution has tails that are as thick as the Gaussian distributions, that measure should also be 0. So if it's positive, that means its tails are thicker than normal. If skewness is positive, that means it's skewed to the right, which means right tail is longer than the left tail, so on and so forth. Let me first write down some traditional measures of skewness and tell you why I'm not going to use them at all. Okay, this is the skew function in Excel. It's 1 over n minus 1 I think they're also dividing it by s cubed, dividing by the cube of the standard deviation to kind of make it scale free. Measure of kurtosis, the reason we're deducting a 3 because that quantity would have been 3 for a distribution that is exactly normal. The trouble with these measures is they're not robust at all. I mean, a little bit outliers are going to basically take in the stratosphere. Remember, we were worried about that just even for the mean, where that outlier has its own weight. In variance or standard deviation, we were worried about squaring, so on and so forth. Those worries are even magnified here most. And the Excel function for that is Kurt. I'm not even going to calculate it. It's going to roughly give me an idea, but I am more interested in some robust measures. Skewness. There's a measure called Galton skewness, named after the statistician Galton, not the guy for whom the hotel in Louisville was named. I don't even know who that guy is. Probably some sort of politician. Basically does the following, if I'm not mistaken. It's Q3 minus Q2 plus Q2 minus Q1 divided by Q3 minus Q1. If the distribution is symmetrical, the distance between the lower quartile and the median should be the same as the distance between the upper quartile and the median. We're dividing by the interquartile range to make this a scale-free number. And by its very construction, this number is going to be between -1 and 1. It's also nice. -1 is extreme left skew, +1 is extreme right skew. So let's go ahead and calculate that for our variables. I'm just gonna go ahead and copy these. Plus, copy. This one is. I'm gonna do the same thing here. And I'm gonna call this skew. That's the reason I put that in there. Because we're gonna look at the variations of on the Galton skew measure. Instead of using quartiles, maybe we want to use quintiles, which are 20% stuff, deciles, so on and so forth. But just for this, and I took these in on purpose. I calculated them on purpose. Actually, let me just call this Galton. I could have made it automatic, but if you worked out the algebra, it's Q3. Let me see. Oh, I'm sorry. This should be minus. So this is actually Q3 plus Q1 minus 2Q2. Here's my Q3 right here, plus Q1 minus 2 times median, the whole thing divided by the IQR. Actually, I want that number to be whenever it's negative, I make it right. Okay. Sometimes you may not see the things.